Hi students, this is AJ sir. Let's study 9th standard ICSE Math chapter 8b. Now for exercise 8b, we just have to remember three laws. Multiplication becomes addition when you separate the logs. Division becomes subtraction with separate logs. And the power log, which states that if there is a power of n, then we can write it as a coefficient before the log. It comes out of the log. For example, look at this sum, 1.1. We have to convert log 36 in terms of log 2 and log 3. So the first thing we'll do is find out the prime factors of 36, that is 2 squared into 3 squared. Now, whenever there is multiplication, we can do addition of two separate logs. So log of 2 squared plus log of 3 squared. So we have separated them. Next, whatever powers are there, that can go here. Understand that the square is not for log 2. The square is only for 2. So this power exponent can go as a coefficient in the beginning. So this becomes 2 multiplied by log 2 plus 3 multiplied by log 3. So we have simply used the rules to convert this in terms of log 2 and log 3. That's what we'll do for the next sum as well, which is log 4.5. So log 4.5 is log 9 upon 2. 9 is 3 squared. So let's separate them. So that becomes log 3 squared minus log of 2 because there is division. So when we separate the logs, we do subtraction. Again, whatever exponent we have, that goes out. So that's twice of log 3 minus log 2. Now the fifth sum, mark it as IMP. We just have to use the rules here. Subtraction means division and addition means multiplication. Here the logs were separate, we will bring them together. When we bring three logs together, then subtraction becomes division and addition becomes multiplication. Also, when you shift this coefficient inside the log, it becomes a square, which I wrote here. And now just solve this. Division means reciprocal, and I did a square also. And now reduction, 25 ones are 25 threes are, 16 ones are 16 twos are, 81 ones are 81 threes are, 3 3 cut. So what is left is 2. So the answer is log 2. Now in 2.1, the question is to convert this equation into a form free from logarithm. We have to get rid of logarithm. Now remember, 1 is log 10. Log 10 value is always 1. So, first thing we'll do here is this square will become a power out here, and subtraction means division of this and this. Only then can we have a single log on LHS, and a single log on RHS can be written as log 10 because log 10 is always 1. That's the value. By the way, what's the base here? It's 10. That's not mentioned, but we know it's base 10, so no need to talk about it now. And now comparing, so that means x square upon y is equal to 10. Don't think that this is log cancel. No, it seems like that, but we cannot cancel the log. It's just by comparing we see that x square upon y is equal to 10. Cross multiply and you get this equation. See, it's free from log, which is what was asked to do. Now in 2.3, again we have to get rid of the log. I see 3 logs, so first of all I should combine these 2 logs. I want only 1 log on the LHS and only 1 log on the RHS. Only then I can compare. So using the rules, I would say that this a becomes a power, b becomes a power of y, and subtraction means division. So x raised to a upon y raised to b, I get a single log on the LHS, x raised to a upon y raised to b. And on the RHS also, the 2 becomes a power out here. It shifts. So this becomes log of 3 squared, which is 9. On comparing, don't think that log cancel. On comparing, we'll get the final equation without any log. What is the use of studying all this? It is useful. Trust me. But not in school. In higher standards. What? You plan to drop math in college? That's a shame. I want all of you to be mathematicians. The wizards of reality. Now evaluate each of the following without using the log tables. This is an expression. We have to solve it using the laws. So addition. So these 3 logs, I'm going to combine them into a single log. But to do that, I have to follow some rules. Addition will become multiplication, 5 into 8. Subtraction will become division. And 2 will become a power. So that's 2 squared. That is what I will write in the denominator. So 40 upon 4 is 10. And log of 10, we remember it is always 1. See, we've converted this as the answer 1. Isn't math magical? Now 3.3, we'll have to solve it in a similar fashion. First of all, 1 upon 3 will become a power of 125 raised to 1 upon 3. That is nothing but cube root of 125. And 1/5 will again become a power of 32. That is 32 raised to 1 upon 5. That is 5th root of 32. Now if I want to combine the 3 logs into a single log, that's the only way to solve it. The addition will become multiplication and the subtraction will become division. Now cube root of 125 is 5 and 5th root of 32 is 2. If you do prime factorization, this is 2 into 2 into 2 into 2 into 2. And 5th root means take out a group of 5 2's out of the umbrella. So only 2 is the answer. And on reducing, I get the answer as log 10, and we know log 10 is always 1. Next, in the 5th sum, there is an equation given and we have to find the value of x. Note that x does not have any log. So we can't just get rid of log easily. Let's transfer all the logs on the RHS so that only x is left on the LHS alone. And now use the usual laws. 1/3 will become a power of 1/3, that is cube root of 125. 3 will also become a power of 2, that will become 2 cube. So I wrote that here. Minus becomes positive here and positive becomes minus here. So I wrote these terms. The order doesn't matter. Now simplify it. Convert the 4 logs into a single log. Subtraction means this will go in denominator. Addition means multiplication in numerator. Subtraction means division in denominator. And after reducing, I'm getting log 10 and the answer is 1. Now 7.1, solve for x. That means we have to find the value of x. If only I had log on both the sides, LHS and RHS, I could get rid of it by comparing. Well, 1 is indeed log 10. And I'm no longer writing the base as 10, it's understood. And the log disappears, so I'm getting x minus 10 is equal to 10, minus 10 shifts and becomes plus 10, x is equal to 20 is the answer. Easy peasy, isn't it? Now in 7.3, the given equation, I can get rid of the log, but I want only one log on the LHS. So let's combine these 2 logs on the LHS. Addition means multiplication of the numbers. So now the log can disappear, and so this is equal to 5. Do distributive multiplication, open the brackets, 2x gone, minus 4 goes here and becomes plus 4, that's x square is equal to 9. So x is plus or minus 3, but x cannot be equal to minus 3. If it is minus 3, I'll get a negative log, that's not possible. So x is equal to 3. Now 8.2 is IMP. Log of 128 upon log of 32 is equal to x. We have to find the value of x. Now if you see division, don't think that now you'll do subtraction or something. No, that rule was applicable if it was log of 128 upon 32. If there was a single log there, then the next step would have been, let's say, log 128 minus log 32. But here already there are two logs which are divided, so there is no rule out here. One thing we can do is, whenever we see big number, we factorize it. So this is actually 2 raised to 7 if you remove the prime factors, and this is 2 raised to 5. So let's write that first. Now we know the rule that whatever is the exponent can come out as a coefficient. The 5 came out. So the good news is that now log 2 gets cancelled and we get the value of x as 7 upon 5. Make sure you convert it into mixed fraction. Now 8.3 is also IMP. Again, I see the division of two logs. So we can't use a subtraction rule here. But we can simplify this. This is 2 cube and this is 2 raised to 6. But I also see that this is 64 is a perfect square of 8. So although converting it into a power of 2 will work, I'm going to do it differently. I will write here log of 8 square upon log of 8. I can't do much about RHS, leave it as it is. So now this power will come out of the log. So this will become 2 log 8 upon log 8, cancelled. So answer is 2. But that's the answer of log x. I want the answer of only x. Now, just like 1 is the same as log 10, 2 is log 100. So you need to remember these values. Log 10 is 1, log 100 is 2, log 1000 is 3, because the bases are 10, of course. So you see 10 raised to 1 is 10, 10 raised to 2 is 100, and 10 raised to 3 is 1000, and so on. So I'm going to write this as log of 100 because now I can compare the logs and I can say that x is equal to 100. So now you know why it is IMP. Now 9 sum, log x value is given, log y value is given, and we have to find the value of log 10x upon y square in terms of m and n. So let's start with the asked question first. Now here there is only one log, so I can use the rules of log. That is, multiplication will become addition and division will become subtraction. Next, this power can be written out, so it will be 2 log y. By the way, log 10 is 1. Log x is given in the question as m plus n, and log y is given in the question as m minus n, in brackets of course, because when we open the brackets this sign will change, like terms together, and this is the final answer in terms of m and n. Next, true or false, you need to write all the answers in your tuition book. You can even write the logic if you want to. Log 1 into log 1000 is 0. What is log 1? Log 1 is always 0. Log 1000 is 3. Log 1 is 0. Log 10 is 1. Log 100 is 2. Log 1000 is 3. Remember these values. So anything into 0 is 0. So that's true. Next, is this true? No, it isn't. We have two logs here. So we can't use the rules of log. If it was a single log, then this would have been true. So it's false. What about here? Well, again there are two laws. So what we'll do is first we'll write this as 5 squared and the 2 will come out. And then log 5 will get cut. So what is left is 2. That means log of x is 2. Log of x we are getting as 2. But here they are writing x is equal to 2. That's not right. We got the answer as log of x is equal to 2. If we want to find the value of x, we would have written 2 as log of 100. Then log gone. So x answer is actually 100, not 2. So this is false. Next, multiplication becomes addition. But here we already have two logs. So the rule is not applicable here. If there was no second log, if it was just x into y, then this would have been true. So this is false now. Now 11.1 sum. Log of 2 is given as A, log of 3 is given as B. So express this in terms of A and B. Now here, first of all, convert 12 into its prime factors. So I got 2 squared and 3. Multiplication means addition of the logs. The exponent becomes a coefficient. And log 2 is given as A and log 3 is given as B. So the final answer is 2A plus B. Similarly, let's solve log 2 1 upon 4. That is 11.3 question. 2 1 upon 4 is 9 upon 4. That's 3 squared upon 2 squared. Division means subtraction of the logs. The exponents become the coefficients. And log 3 is B and log 2 is A. So the answer is 2B minus 2A. You can even remove 2 common. So the answer will be 2 in brackets B minus A. Now question 11.6, mark it as IMP. So we'll first convert the mixed fraction into an improper fraction. Now this is 2 cubed, but this is 5 squared, and we need to convert everything into 3's and 2's. But I'm not getting a 3 or 2 out here. So what we'll do is, we'll do into 4 into 4. Because by doing that, this becomes log of 100 upon 32. Now, division is subtraction. That's log 100 minus log 32. And 32 is a power of 2. 2 raised to 5. And log 100 value we know, 2. And this becomes 5 log 2, which is 5a. So ultimately we have got the answer in terms of 2 or 3 or both. In case only in terms of 2, log 2. Now 12.2 is similar to question 11. But here the values of log 2 and log 3 is not given in terms of A and B, but actual values have been given, which we'll have to use and find the final answer. So first of all, convert 1.2 as 12 upon 10. Division becomes subtraction. Log 12 is log 2 squared into 3. And log 10 is 1. Now again here, multiplication becomes addition. The power becomes the coefficient. So 2 log 2 plus log 3 minus 1. Log 2 value is given 0.3010. Log 3 value is given 0.4771. Multiply this by 2, add them, subtract this, and the final answer is this. Next, 12.4 is log 15. Now 15 is 3 into 5. Again, I don't want a 5. I want 2's and 3's. Or even 10's and powers of 10's are fine. So let me convert 15 as 30 upon 2. Because then that would become 3 into 10 and upon 2. Which is same as 15. That's good because we know 3 log 3 value, we know log 2 value, and log 10 we know is 1. So that will do. Multiplication becomes addition and division becomes subtraction. Substitute the value, we know this value. Substitute this value and we know this value as 1. And add and subtract to get this answer. Next, 12.6. Here I know that 8 is a perfect cube of 2. 8 will become 2 cube. So what I'll do is this 2 upon 3. This 1 upon 3 part, it's 2 into 1 upon 3, right? 1 upon 3, let me take it out here. So it will become 8 raised to 1 upon 3. The upon 3 out here in the coefficient has been shifted to the power. Why? Because 8 is 2 cube. So I'm going to get 3 cut. So only 2 will be left behind here. Yeah, if I send this also here, it will become 2 squared, which is 4. But I don't want a 4. I want log 2 because log 2's value is given, which we can substitute and get the final answer. 13.1 is IMP. In the given equation, we have to get the value of x. Now remember, don't think it is log of x plus 1. There is no bracket out here. This 2 log x is a separate term and plus 1 is a separate term. Let's write that also in terms of log 10. and the base is 10. That's understood. I'm not going to write that again. The coefficient becomes the power out here, and addition means multiplication, so that becomes a single log of 10x squared, and here it is log 250. So by comparing, the log disappears. 10x squared is 250, 0 0 cut, x squared is 25, square root plus or minus 5, but negative values are not allowed in log, so answer of x is 5. Make sure you write the proper question number. In question 15, they've asked us to find the value of log this in terms of a, b and c, and these are the values given. So we'll start with what is asked, and we'll use the laws of logarithm. I see a multiplication here, so log of 10 plus log of root y. Root y means y raised to half, and the power of half can go out of the log. Next, division means subtraction, so minus 2 log x. How did the 2 come here? Well, it was x squared, right? So the power came out. Similarly, it was z cubed, so the power came out. So I've converted one log into 4 logs. Now let's substitute the values of y, x and z as given in the question. So after substituting, I simply get this. Now these are powers of 10, so let's write it like that. So this becomes 10 raised to 4b, and this is 10 raised to 2a, and this remains as it is. Now again, the powers will come out of the log, out of the log, out of the log. So it becomes 4b out here, 2a out here, and c out here. And we are left with log 10s, and you know that log 10 is always 1. So that disappears, and we are left, after solving, we are left with this answer in terms of ABC as wanted.